A very good morning to doctors. We are from Session 2 Group 1 are going to present our highway engineering group projects with the title of Evaluations of Pavement Distress along 1 kilometer route at Taman Manis Pariraja. In our group, we have Lawson Yuan, Lawson Lin, Mi Pang Fei Ching, and also Wong Yi Moon. Introductions. Roof pavements are the backbone of infrastructure designed to distribute vehicle load effectively while providing stability, comfort, and safety. Premature failure caused by the factors like moisture and temperature variations can compromise performance. So pavement condition index (PCI) is a practical and cost-effectively tool to monitoring road surface, ranging from 0 to 100 and 100 being ideal, and PCI assess pavement condition based on the distress type and he guide maintenance and rehabilitations effort to ensure funds are used wisely. So the ASTM has classified PCI into 7 classes. First classes is 85 to 100 is characterized as good, 70 to 85 as satisfactory, and 55 to 70 as fair. And 40 to 55 consider bad, 25 to 40 consider extremely poor, and 10 to 25 consider sour, and also lastly 0 to 10 is considered failure. The objective in this investigation is to determine the performance pavement condition in test PCI and identify the type of distress along 1 kilometer road at Taman Manis Pariraja, Johor. And the second one is to study the maintenance and rehabilitation method to improve the road pavement condition. Literature review. The pavement condition in test PCI serve as the part of road infrastructure crucial for ensuring safe and effective travel. In groundbreaking research by Vitalis Num 2020, the traditional PCI methodology was revolutionized by incorporating 9 distress criteria and the international roughness index. The finding revealed that combining factors for PCI assessment provide more accurate results than relying on a single parameters. Mohammad Shalim Zahra 2019 conduct a condition survey on a nation highway used visual distress assessment to estimate PCI. Uncovering 10 out of 19 pavement failure, the study have identified pothole, ratings, spot cracking, and more. So next, a study from Professor Dr. Faris M.A. Karim's 2016, the evaluations of R-Fridge route in Yemen took center stage. Using the pavement condition index PCI, a comprehensive method for identifying surface distress, the study provides crucial insight to the route health. The study significantly in its strategy approach to maintenance and rehabilitations, tailoring solution based on the specified distress type and also severity level. This research not only ensure the longevity of the route, but also optimize maintenance resource in a context of limited fund in Yemen.
Now, I would like to present about methodology. In our group project, we conduct a comprehensive assessment of the pavement condition index along the 1 kilometer stretch of Taman Manis. Based on the rating for PCI value, we can understand the current road condition for each 5 sections in 1 kilometer route at Taman Manis 7. In our project, we use pavement condition index method, which is a numerical scale commonly applied to evaluate the operational state and structural integrity of road surface. In calculating PCI, the result of a visual inspection that identify the type, severity, and quantity of distress are used. Step 1. We determine the sampling interval by using the formula, which equal to total number of sample unit in section divided to minimum number of sample unit to be inspected. Step 2. We inspect the sample unit. During inspection and observation, photo were taken to determine distress type, severity level, and measure pavement density. Step 3. We need to determine data value. Before it, the total for all distress type at each severity level are added and recorded, and after that, we calculate the percentage of density for every distress type and severity in each sample. After these two steps, we just can get the data value for every distress type and severity level combination from the distress data value curve for asphalt concrete pavement. Step 4, we need to decide the maximum allowable number of data. Since the individual data value are greater than 2, we're using the procedure below. The individual data value are listed in descending order, and we determine the allowable number of data by using the formula, which is equal to 1 plus 9 over 98 times 100 minus highest data value. Step 5, we need to determine maximum corrected data value CDV. Before it, we summing individual data value and determine Q as the number of data with a value greater than 2. After that, we determine the CDV from total data value and Q by looking out the appropriate correction curve for asphalt concrete pavement. Reduce the individual data value which are greater than 2 to 2. After this, we repeat step 1 to step 5 until the value of Q is equal to 1. After this step, we just can determine the maximum CDV, which is the largest value of the CDV. Last step is we need to determine the pavement condition index by subtracting the maximum CDV from 100, and the condition of the road is determined by using the PCI scale.
Now, I would like to present the result of Session 1 in Jalan Taman Manis 7. There are 6 distress in this session, which are low alligator cracking, low longitudinal transverse cracking, low patching utility, cut patching, low potholes, medium potholes, and the median showing. After that, we calculate the quantity and the total quantity, percentage of density, and the deduct value. Next, we find the maximum allowable number of deducts. The highest deduct value is equal to 48. After that, we substitute the value into the equation. We found that the maximum allowable number of deducts is equal to 5.79. The number of deduct values is equal to 6. Since the maximum allowable number of deducts is equal to 5.79, therefore only the first 5 and the 0.79 of the 6 deduct value are selected. Next, we find the maximum corrected deduct value. The number of deduct value greater than 2, then Q is equal to 6. We found that the total deduct value is equal to 110.16. From the figure B45, we found that the corrected deduct value is equal to 54. Reduce the smallest individual deduct value to 2, Q is now equal to 5, and determine the CDV. Repeat until Q reaches 1. This is the table we calculated. The maximum corrected deduct value is equal to 64. Determine the pavement condition index by using the formula 100 minus corrected deduct value. We get in section 1 is 36. Based on the rating for PCI value of 36, this section of pavement is in very poor condition. Now I would like to present section 2 in Jalan Taman Manis 7. There are 4 distress in this section, which are low alligator cracking, low land or shoulder drop-off, low patching and utility cut patching, and the last is low potholes. We found the total quantity, the percentage of density, and the deduct value. Second step is find the maximum allowable number of deducts. The highest deduct value is equal to 65. Then we substitute the value into the formula. We can get the maximum allowable number of deducts is equal to 4.21. Deduct value is in descending order, which is 65, 9, 6, and 2. The number of deduct value is equal to 4. Since the maximum allowable number of deducts is 4, therefore only the first 4 of the fourth deduct value are selected. For example, 65, 9, 6, and 2. For the step 3 is find the maximum corrected deduct value. The number of deduct values greater than 2, then Q is equal to 4. The total deduct value is equal to 82. From the graph which is figure B45, the corrected deduct value we get is equal to 46. Reduce the smallest individual deduct value to 2, Q is now equal to 3, and determine the corrected deduct value. We repeat until Q reach 1. This is the table we calculated. We found that the maximum corrected deduct value is equal to 71. To determine the pavement condition index, we use the formula which is 100 minus the corrected deduct value. We get the PCI value is equal to 29. Based on the rating for PCI value of 29, this section of pavement is very poor condition.
So I'm going to explain about the section 3. At section 3, we have found that the defect is 04 pop and slash, 06 depressions, 09 land shoulder drop off, 11 punchings and utility, and also 17 is seepage creaking. So now we proceed to the maximum allowable number of deduct m. To get the number of deduct m, we need to get the highest deduct value, which means in here is 50 based on the table above. So by insert the 50 inside to the equations, m equal to 1 plus 9.9 times 100 minus 50, we can get 6.05, and deduct value in descending order will be 50, 9, 8, 4, 3. So number of deduct value is 5. Since the maximum allowable number of deduct is 5.5, therefore of the deduct value are selected is 51, 9, 8, 4, and 3. So in set 3, maximum corrected deduct value CDV, number of deduct value greater than 2, that means Q equal to 5. So from the figure B minus 4, 5, CDV is equal to 38. By using the table of deduct value, we can get the maximum CDV is 58. So to step 4, determine the pavement condition index, CI equal to 100 minus CDV maximum. That means 100 minus 58 is 42. So based on the ratings for PCI value of 42, this section of the pavement is in poor condition.
Now I would like to present about the result for section 4, which is at Jalan 7/1, Taman Manis 7. I get 7 type of distress in this section, which are medium alligator cracking, medium bleeding, low bump and sweat, low longitudinal and transverse cracking, low potholes, high potholes, and medium slip head cracking. After that, I calculate the quantity, total, and density. I also get the deduct value from the deduct value curve for each distress. Step 2, I calculate the maximum allowable number of deduct by using the formula 1 plus 9 over 98 times 100 minus higher deduct value, which is 48. I get 5.78. After that, I rearrange the deduct value in descending order, and since the maximum allowable number of deduct is 5.78, therefore only the first 5 and 0.78 of the 6 deduct value are selected. Step 3, I determine the maximum corrected deduct value. Before it, I calculate the number of deduct value greater than 2, so I get Q equal to 6, and I calculate the total deduct value, and I get 106.12. After that, I determine the CDV until the Q reach to 1. After determine the corrected deduct value until Q reach 1, I get the maximum corrected deduct value is 62. So I determine the pavement condition index by using the formula 100 minus maximum corrected deduct value, and I get 38. Based on the rating for PCI value of 38, this section of pavement is very poor condition.
Now we come to the last section, which is section 5. Follow the steps that show in methodology, we can get the value of PCI, pavement condition index. In section 5, we have found bleeding, bumps and sags, depression, potholes, and slippage cracking. And the quantity of those problems and the total value, density, deduct value is shown in the table. Now we move to step 2 to get the maximum allowable number of deducts m. The highest deduct value HDV equals to 22. M equals to 1 plus 9 over 98 times 100 minus HDV, which is 22. We will get the value of m equals to 8.16. And then we arrange the deduct values in descending order 22, 8, 4, 3, and 2. Number of deduct values equals to 5. Since the maximum allowable number of deducts is 8.16, therefore, of the deduct value are selected such as 22, 8, 4, 3, and 2. Now, step 3. To get the maximum corrected deduct value CDV, the number of deduct values greater than 2, Q equals to 2. Total deduct value equals to 22 plus 8 plus 4 plus 3 plus 2 equals to 39, From figure B-45, CDV equals to 18. Reduce the smallest individual deduct value to 2, Q is now 4, and determine the CDV. Repeat until Q reach 1. As we can see, we arrange all the deduct values into a table, and we get the total values of the deduct values, and then we arrange the Q and the CDV values. We will get the maximum CDV equals to 30. And then we move to step 4 to determine the pavement condition index, which is PCI equals to 100 minus CDV maximum, which is 30. So that 100 minus 30 will equals to 70. Based on the rating for PCI value of 70, the section of pavement is in satisfactory condition. Now, let's getting it into the discussion part. We have unit sample for 1, 2, 3, 4, and 5. And the pavement condition index for section 1 is 36, for section 2 is 29, for section 3 is 42, for section 4 is 38, and the last one for section 5 is 70. The placement condition for unit sample 1 is very poor, for unit sample 2 is very poor, for unit sample 3 is poor, for unit sample 4 is very poor, and the last one for unit sample 5 is satisfactory. For unit sample 1 and 2 is located at the entrance of Taman Manis, Pariraja. This is the main and only way to Taman Manis, so most of this route is used by the resident of Taman Manis. There's a row of shops and car repair shops on the left-hand side of this route. It's been observed that no less than 20 heavy vehicles pass through this route every day in order to replenish the merchants, such as alligator cracker, land shoulder drop-off, utility cut patching, potholes, and bleeding will be happens due to this situation. All these reasons make the road condition become very poor for sample unit 1 and 2. For units number 3 and 4 is located at Jalan 6/6 and Jalan 7/1 Taman Manis. It's a common area for Taman Manis. Everyday traffic on that road is inevitable for the residents of the Taman Manis playground on the left and the terrace house on the right. This will lead to potholes, bumps, and sags. Owing to a lack of parking spaces within Taman Manis, tenants frequently park their cars outside and building on the side of the road. This will lead to pavement edge cracking. In conclusion, the pavement condition of unit number 3 is poor and unit number 4 is very poor. For the last section of our project, unit number 5 is located at the end route of the Taman Manis. This road is a dead end, only bears minor traffic since it's only used by some new terrace house residents. This situation will lead to potholes, bumps, and sags. Pothole and depression are found in unit number 5, which may be caused by the environmental conditions, such as change in temperature, freeze-thaw cycles, and the water infiltration can all contribute to the deterioration of the road surface, so that the pavement condition of sample unit 5 is satisfied.
Now, I'd like to present the maintenance or rehabilitation method to increase the PCI value. The first method is reconstruction. For the pavement condition of sample 1, 2, and 4 is in very poor condition, and the pavement condition of sample unit 2 is in poor condition. There are 3 types of construction, which are removal of existing road surface, reconstructing or rehabilitating the road bed, and the placement of new road surface. The second method is routine and preventative maintenance. This is for sample unit 5, which have satisfactory pavement condition. It includes pothole repair, repair of road shoulders, furniture along the side of the road, drainage system, bridge, and culverts, as well as routine maintenance and landscaping on protocol route examination. In conclusion, from the route of Taman Manis, we found that they have slight alligator cracking, edge cracking, land or shoulder drop-off, patching and utility in route, potholes, slippage cracking, longitudinal and transverse cracking, bump and sags, depressions, and bleedings. The average PCI of the route is equal to 43. It's indicating that the route is in poor conditions. The suitable maintenance and rehabilitation method are reconstructions for very poor and poor condition, while the routine maintenance and preventative maintenance are suitable for satisfactory pavement conditions.